My name's Tammy Pierman. I'm a member of the CSTA board, and I am very happy to welcome you to this particular session, which is Advanced Placement CS Principles, Course and Exam Overview. Your presenters are Leanne Diaz, Deepa. She's just Deepa.
Yeah, there you go. Deepa for friends anyway.
Rich Kick and Fran Trees. Your speakers will introduce themselves. I have just two very short announcements to make before we start. I would like to remind you that after this session, we will have lunch at 12:30 in the St. Charles Ballroom. This is the location where the keynote speaker was this morning. Also, we have, for the first time ever, an exhibitors hall, and we would very much appreciate it, and I know our exhibitors would very much appreciate it, if you would find a few minutes to walk through that hall. They will be there until 4:30 today, and they are in Marsalis 1 and 2, which is just off of Bourbon Street. Thank you.
Okay, great, thank you. I am not intimidated by that bright, shining light at all, really. That's right. No, thank you all for coming to our session this morning. We're very happy to be here. We want to share some updated information about the course and the exam with you all. My name is Leanne Diaz. I am with the College Board in the Advanced Placement program. I've been working on this project or developing the course curriculum framework for a little over 5 years now. So I'm, I see a lot of familiar faces, but I also see a lot of new faces. So we're very excited about that. On the panel, we have Rich Kick, Fran Trees, and Deepa Muralidhar, all on the AP Development Committee for this course. And we have a few more Development Committee members in the audience as well, or here at the conference. So we'd like for you to take the time to get to meet them and get to know them when you can during this conference today. Anything else you'd like to say about? Okay, great. So we're going to go ahead and get started. Push this here. So what I'll do first is provide an overview of the curriculum for the course, its components, the components of the curriculum framework, and then we'll move into the assessment. And along the way, I'll ask the panel to chime in on different aspects of the course and the exam. They'll also have, a lot more to say about the assessment itself, since they are on the development committee. First, we want to note that there are some major themes in the curriculum framework for this course. The curriculum provides a pathway for students, and we do say, especially for females and underrepresented students, to consider studies in computing. The former committees that were involved in discussions and framing the curriculum framework had lots of discussions about what would elicit, excitement and engagement with minority students and females. The curriculum is engaging, requiring students to be creative and consider impacts of technology on society. We want students creating computational artifacts, and we'll talk a little bit more about that in later slides. I also want to say that another theme of this course is that, programming is not a focus, it's not the central focus, but it is an important aspect of the course. We do consider it an important piece of computer science studies. So it is one of the big ideas. But unlike many other, first semester college computer science courses, or what you would consider your first course in computer science, or typical first course computer science, it is not necessarily all about programming, though it is a very important part of the course. And also, the curriculum focuses on computational thinking and fluency. We looked at, some research around computational thinking and provided some very important computational thinking practices in the curriculum framework. So those are 4 major themes that run through the curriculum framework. A show of hands before I introduce the development committee. How many high school teachers do we have in the audience right now? Just a show of hands. Awesome. How many college professors, college or university professors in here? Very good. And one last question. How many of you are new to sort of, knowing about computer science principles? Raise your hands. Okay, so we do have a few of you in here. That's great. So what is new about this second phase of course and exam development is that we have impaneled an AP Computer Science Principles Development Committee. All of our AP courses have a development committee. This is it. This is the inaugural development committee for Computer Science Principles. Rich Kick, Fran Trees, and Deepa are on the panel. We also have Dan Garcia, Christina Gardner-McCune, and Dale Reed and Andy Kimmel as well on the committee. It is a makeup of 7 members, high school and college members. We have 4 college professors at the moment and 3 high school teachers. 5 of them are pilot instructors. They've been piloting with us for a few years, if not, more than that. So it's a really, really good makeup with background and experience. All right, so I want to say a little bit about the makeup of the curriculum framework. If you haven't seen it already, it is accessible on a College Board microsite. I will provide that address on a later site, but if you go to collegeboard.org/CS Principles, you can access the updated curriculum framework. Owen Astrachan, as many of you know, also has a website called csprinciples.org. The curriculum framework is also accessible there. I wanted to spend just a few minutes on the important components of the curriculum framework. So there are computational thinking practices. You can consider these sort of the skills of the course that students will acquire. There are big ideas, 7 major themes, you could call them, that we consider a major focus of the course. We have things that are called enduring understandings. And more importantly, we have learning objectives and essential knowledge statements. I mentioned these components in the curriculum framework because each of these has a purpose. We want to convey, a sense of the skills and the big topics, the big important topics in computer science principles, but at the same time provide a level of detail for teachers and for educators to know what exactly is going to be assessed on the exam. And the assessment is based on the learning objectives and the essential knowledge statements that are included in the curriculum framework. So the level of detail goes from, the computational thinking practices and the big ideas, sort of providing that scope of the major themes in the course, down to much smaller level of details to what exactly will be assessed with the learning objectives and the essential knowledge statements. So let's start with what the computational thinking practices are in the course. We have connecting computing. We want students to describe connections between people and computing. We have creating computational artifacts, a big theme and big skills that we want students to do is create computational artifacts. The panel will have a little bit more to say about that. Abstracting, we want students to explain how data, information, knowledge is represented for computational use. Analyzing is important. And then, of course, communicating and collaborating. We want students to collaborate to produce artifacts together, to solve problems together. We want them exchanging knowledge and feedback, and perhaps even, to resolve conflicts while solving a computational problem together. Those are just some of the types of skills that you can anticipate students acquiring in this course. I'm going to turn to the panel to either maybe Deepa or Rich, who are high school teachers, that might be able to comment more about these kinds of skills that they've been able to introduce to their students. Would you like to comment?
I will tell you that a big part of this course is not just me introducing things to students, but students introducing things to me and each other. I use a course management system called Piazza, and on that I will make presentations, I will provide links to information, but as I went through recently my 3 years of piloting and I looked at the things the students did, they inspired so much of the course. So we do have these big ideas, the 7 big ideas, the creativity, the abstraction and data, the algorithms and programming, the internet and impact, but we also have these computational thinking practices that are all inspired and motivated by a lot of the things the kids are interested in. As Owen Astrachan always points out, I'm very into the passionate term. I look for students' passion and those ideas that they're really interested in, is what drives me to move them in directions and hopefully find information and experiences that will help them pursue those passions.
And if I may add, the way I present to my students is, you've got to know these big ideas. That's where the rubber meets the road. The computational thinking practices are the essence of the course, if you will. They flow right through all the big ideas. So whether it's computing, connecting computing, or communication, or collaborating, or trying to understand abstraction, it's not something that you learn with a specific learning objective and then you say, okay, I'm done with this CT. So when I talk to teachers, and I'd like to present the thought here, it's not one of those things that you say, okay, in August, I'll start with computational thinking practice number 1 and be done with it. It is something that will just go evolved right through the course.
Thanks. Thank you. Okay. So we'll move this along into showing what the big ideas of the course. I'm not going to go through each of these in great detail, but these are, you could consider these the 7 major themes of the course. Creativity, abstraction, data, algorithms, programming, internet, and impact, how computing impacts the world. So in each of these big ideas, you will see, Deepa mentioned, you will see the computational thinking practices interwoven throughout each of these big ideas. Again, I had mentioned that, even though this is not a programming focused course, we do consider it to be an important aspect or important part of studying computer science principles. I want to maybe dive just a little bit deeper into the level of details that's provided in the curriculum framework. This is just one example of the breakdown of the different components. This is an example for the first big idea, which is creativity. Again, a huge theme right throughout the course. We have enduring understandings, and the enduring understandings are denoted in green on this slide. These are statements that summarize important ideas and core processes that are central to CS principles, and these can also have lasting value beyond the classroom. So if you go down another level, what we have are learning objectives, and these are really important in the curriculum framework. The learning objectives are the targets of measure for the AP exam. So as the development committee works on the assessment, on the exam, they look at the learning objectives, they look at the level of detail associated with those learning objectives, and the items and the questions and even the performance tasks all assess these student expectations. So for example, 1.1 is the enduring understanding is computing fosters the creation of artifacts. And the 3 learning objectives under that are denoted in blue. 1.1.1, use computing tools and techniques to create artifacts. That is the student expectation. Students will create computational artifacts. 1.1.2, collaborate in the creation of computational artifacts. And 1.1.3, analyze the computational artifacts. Yes, sir?
What's an artifact?
Very good question. I'm going to turn that over to the development committee for their description of it. Would you like to?
Really, it's wide open. It's anything that the students create digitally. We've had some really, really great student submissions. Some of them are presentations. Some of them are infographics, videos. So it's a wide range of computationally created projects.
Right, and I'll just add to that, for the performance tasks, which we'll talk about in just a second, we are asking students to submit those digitally. So they have to be able to save it somehow in some kind of format that can be submitted electronically. It could be a picture, it could, and we're asking for PDFs as well, too.
I will mention that this is similar to what they experience in the art world as well. Obviously, not all art is in digital form. So I had students who actually created artwork that was physical. You could touch it, but then they also created a digital version of it that they could share with me. So this course is all about creativity, and it's certainly not about restriction or suppression. So they can do things in a variety of ways, but eventually they have to be able to digitize it to actually submit and share with other people.
That was a really good question, by the way. I'm sure other people had that same question.
Thank you. Thank you.
Can I add just real quick?
Dan Garcia, one of the development committee members.
The program that they write is also an artifact. And you can write a program that writes a picture, that draws a picture. That's also an artifact. So the thing that does the doing, the program, that's an artifact as well as whatever the program created as output. Kind of neat that way.
Is a Microsoft Word document an artifact?
Well, as part of the write-up and reflection that students have to do for the performance tasks, we would consider that an artifact. Yes. But
I would say that if you are using a word processor to create a document, you wouldn't necessarily use computational thinking practices to create it. So our emphasis is not only is it in digital form, but what is the process you use to create that artifact.
And also don't forget, it's the process, that's the appropriateness of a tool. If I used Microsoft Word to design a web page and saved it as a .html, you know, how valuable is that? As versus, let's say I used Wix to create a website, and then I took a movie of it and I turned it in. So while there's process that's definitely important, the computational thinking process that's important, also the applicability of the tool to convey the intent of what you're trying to do. All three would be equally important.
so as we talk about the actual performance task or the description of what we would expect or anticipate as part of student submissions, I think we can have deeper conversations about the kinds of artifacts that we have already received. We're still continuing to pilot them, so we hope to learn more about the kinds of artifacts that students will create. This last slide about the curriculum framework shows all these pieces coming together. Putting together the computational thinking practices, the big ideas, and then enduring understandings, we have developed the very specific statements, the learning objectives and essential knowledge statements. And I just want to reiterate that this is where all AP exam questions are based on, the learning objectives and the essential knowledge statements here. All right, so a new feature of the updated curriculum framework, if you are interested in taking a look at that, is the addition of what we're calling exclusion statements. So while we wanted to provide teachers and educators, a very specific scope of understanding of what is included in the course, the development committee also felt like there was a need to make some statements or provide some statements about some things that would not be considered part of the assessment piece in particular. So for example, the second bullet denotes what learning objective 421 is, which is under the big idea algorithms. One of those learning objectives is explain the difference between algorithms that run in a reasonable time and those that do not run in a reasonable time. We added an exclusion statement to that learning objective that states, discussions of non-deterministic polynomial is beyond the scope of this course in the AP exam. It's not that we don't want you to teach it or that you shouldn't teach it. We're not making a claim or statement about that. We're just stating that that would not be on the AP exam. And I'm going to turn to the development committee to provide more details as necessary.
How many people in this room have taught AP CSA? So that's a large percentage of you that know that there is this exclusion about CHAR, C-H-A-R. It is a type that's very useful, yet it is stated that it will never be a topic on an exam. So that's the spirit of this. There are many ideas that you could discuss with your students, teach, but wouldn't necessarily expect them to be prepared to answer those questions on an exam. And this example was one. We also had one with binary and specifically two's complement. Those are the kind of things that you don't have to stress about in terms of preparing your students for an exam.
The exclusion statements are there to help guide the teachers as to the scope of the course, and they appear throughout the entire curriculum framework.
All right, so this is just an example. Yes, sir.
What does reasonable mean?
Good question. Not no, I don't know. What do you want to? How do you want to respond?
So
Polynomial time, that you could model the time connecting the amount of data and the time taken to complete the task with a polynomial.
But this is a good question because one of the other sessions that we had, someone said, well, if it's an exclusion statement, do I have to understand what it says there? Should I go and get in a state of panic because I don't even understand what the exclusion statement means? And the answer to that is no. Don't get in a state of panic. You don't have to teach it. Certainly, if you want to know more than your students, you can go out and try to learn what the exclusion statements are saying. But if it's there as an exclusion statement, you do not have to panic. You do not have to teach that. That's beyond that scope of the course.
So what I hope will help answer your question is that in this slide, what we show are the three main columns that are included in the curriculum framework. To the left, we have the enduring understandings listed. In the middle column, we have the learning objectives listed. And then in the right column, we have a set of essential knowledge statements that accompany each learning objective. And so in this example, if you look at 421B, we've included an essential knowledge statement that I think helps provide a scope around what we consider reasonable time to mean for this course. So you have to kind of dig down into the level of details in this third column, to better understand that scope for each learning objective. Okay. All right, so that concludes the overview portion of the curriculum. What I'd like to move into now is I'm going to turn it over to the development committee to talk about the assessment portion. We just have a few slides on that, and then we'd like to open it up to a Q&A session with the audience. So, do you want to do it from there? You can do it from there.
Sure. So, unlike other AP courses, this AP course it does have two parts. The first part is a computer-based exam. So the students will not have a paper, pencil, multiple choice part of the exam. It will all be computer delivered. That allows for some very creative types of questions. The types of questions the students may see on this portion of the exam: single and multiple select questions, so not only single multiple choice questions, but also choose two of the above that satisfy something. Drag and drop, perhaps drag the order or the abstraction levels in a certain order. So they actually drag and drop things right on the screen. Hotspots, perhaps click the quadrant that this particular robot would end up in, given the execution of a code segment. And short answer, so short answer, written responses in a text box, so to speak. In addition to that, there are three course assessments, which are the two performance tasks. Those two parts together will give the student one AP score, and the AP score will be similar to the AP scores in other areas.
So I personally think this is an incredibly exciting time to be in computer science education, because for years we have speculated on being able to give students assessments that were dynamic, that were live at the moment, and allowing them to more than just select a possible response, but actually create a response and have it still be graded relatively quickly. Still going to be automated, so it's objectively scored exam through a computer. So at this time, we're going to have students on computer solving problems, and then still also have those project-based assessments that we've all given in our courses throughout the year, but now have that as part of the formal College Board assessment. So this is a pretty incredible time for me and probably a few others of us that have been in here for 30 plus years, seeing the assessment evolve.
I'd like to emphasize that why the word there, through course assessment. We have two performance tasks. It is expected that in the classroom we teach them from day one. We do want the students to take the performance task towards the end of the course. So if this is a year-long course in spring, somewhere in March or April is when you expect them to take both the Create as and the Explore PT. But teaching probably should happen from day one. And while the name makes you think that Create is programming and Explore possibly is impact, when we made through various conversations and discussions, both as pilot instructors as well as in the development committee, one of the biggest things that we like to emphasize is that it's not just one particular big idea. For example, if the Create PT, definitely it's programming. There are the learning objectives are from the programming big idea, but so there's also the abstraction and the algorithms and the creativity for sure. Similarly, in the Explore PT, we have the impact, some of the internet, and creativity again, and possibly the algorithms and the data and the abstraction.
And this part actually replaces the free response part. So there are no free response questions on this exam. This is the free response part.
Right. Yes, question.
I just wondered, have you decided yet whether it's 50-50 or is it 50%, 50%?
Um,
Aren't you sure?
What do you want to? So I can respond and then you can add. It is not exactly 50-50. The final assessment design will likely show that there is more. There will be a little more weighting to the first component, to the actual the objectively scored section, and all of that information will be finalized fairly soon. Fairly soon. So what I'd like to do is ask the development committee to provide some more input and their perspectives on the create and explore performance tasks. We'll start with the create task.
The create task, again, these performance tasks have recently been revised. They are very readable. The create performance task requires the students to work collaboratively on one part of it, individually on another part of it. So on the collaborative part, the students have to work together to write a program and to do a write-up that answers questions about the program that they wrote. In the performance task, we affectionately call them PTs, so you'll hear us saying PTs all the time. In the performance task, in the create performance task, we actually have in the document what we mean by working collaboratively. And that stemmed from receiving submissions from the pilot students and instructors where we would read what the student meant by collaborate, and the student would say, well, my partner wrote the program and I did the write-up because he could write programs and I don't know how to write programs. Well, that's not what we wanted to see. So we actually gave some suggestions as to what we mean by working collaboratively so the students would have a better understanding of that. So collaboratively, they write a program and they do a write-up. And individually, they write a program and they do a write-up and a reflection of the collaboration that they used for the collaborative part of the PT. So they're working both individually and collaboratively and submitting several pieces as far as the submission for the whole PT goes, which includes a video of their running programs.
And for the Explore PT, they will be allowed to work on their own and pursue those things that are most interesting to them. Look at the impact that computing has had on society. Find the things that are personally interesting to you. Impact is a tricky idea. I think the gentleman in the second row will appreciate the fact that impact is not necessarily well defined. Is something impactful that it makes a large impact on your life but not many other people's lives? Or is it impactful if many people are impacted but only a small amount? So we tried to address both of those issues and said that if a student comes up with an innovation that has impacted a few people's lives significantly to a large extent, we're going to consider that a legitimate topic to choose. And if someone picks something that is not a large impact on any individual's life, but it impacts a lot of people, that also would be a legitimate topic that they could choose, and then they can write about this. I think an exciting part about this is, again, writing through submissions that are specifically guided through prompts. So instead of having a large essay that I'm sure if anyone's going to be a reader, they may cringe at the fact that they'd have to extract this information, it will now be specifically focused by prompts, and students could write to those specific prompts and therefore make it a little easier for the readers to assess whether or not that student correctly addressed them.
There are two main deliverables. While finding an innovation that had an impact, we try to emphasize that the student should try to make it a research activity. So to that effect, try and find a research paper. Give citations. So we really do want to teach the students how to put a citation up. The document talks about having references of less than 2 years. The other deliverable is an artifact, and there's a slight change from last year for those of you who looked at it earlier. The artifact does not specifically just say, tell me about your innovation or tell me about the impact that this particular innovation has had on society, but very specifically talk about what are the benefits or what are the harm, maybe both, and try to have some sort of a computational digital artifact as a deliverable that has to be turned into College Board for a grade.
Great, thanks. I think I'm going to skip through those and actually move into a Q&A, quick, Q&A session with the audience. I'm sure there are some questions that you'd like to ask, and we would like to have an opportunity to, answer those questions as well. So I'll take those questions now, and I'll moderate for the development committee. Yes, sir.
I think I understand what the create task is. I'm not exactly sure what they're supposed to do for the explore task.
So the question was, what our kids exactly are expected to do for the explore task? Is that correct? Yes.
Go.
Go ahead.
So for the explore task, the students are expected to turn in a research paper answering specific prompts, and then turn in a digital artifact which expands on the benefits and harm that particular innovation has had on society. The digital artifact could be a video, it could be an audio file, it could be a website, something that is meaningful to a student. The focus really is to try and get the student to display or demonstrate that they have a deep understanding deeper understanding into the innovation, if you will.
So Jim, I'm not going to read the whole thing, so I'll just give you a few of the prompts so you get a better idea of what the student would actually have to do. So one of them says the innovation name and description has to be given, an explanation of the technical details of this innovation in terms of that someone would completely unfamiliar with the innovation would understand. So you have to describe what it is that they picked as a significant innovation in detail that someone not knowledgeable about it would understand. A description of the role computing plays in implementing the functionality associated with that innovation, and then a description of the relationships between data in the innovation. So those are a few of the things that students would have to address when writing their prompts.
Is there a time limit for actually producing the?
We're all smiling because we've had significant discussions on time requirements. And obviously, a main purpose for this course is to address equity issues. And so we'll say that definitely we are going to require a certain number of hours in class time that students are going to be allowed to work on these performance tasks. This is to address the issue of the students who have no technology at home, they have no internet access at home. If we require that students and teachers are given time within the classroom to work on these, that will hopefully help those students who do not have that kind of technology to be able to still complete the performance task.
All right. So on the, I'm sorry, go ahead.
But they can still use time outside of class, so therefore some projects can clearly be.
There are
more
some things we can
expensive.
control and some things we can't.
Okay. Next question, sir.
Can
Yes.
students do the same projects in the same classroom? That is, work on the same thing?
So it's not
themselves?
collaborative. The Explore is a single,
What?
Explore is not collaborative.
Yeah, they have to be unique projects.
You would,
Okay. Then they use outside consultants, otherwise known as friends and parents, to advise them on how to do it and how to write it up. And
The performance task directions indicate to the students that they should work on this alone. This is like a free response question on an exam.
Right. So I'll say two things. One is that it is the expectation that teachers will provide students with plenty of experience with performance tasks, with projects, to obtain the knowledge that they need to successfully complete the performance tasks as indicated in the guidelines for each task. So if a student is working on the Create or the Explore task, they've already obtained enough knowledge and information about how to go about to complete it individually or as indicated in the task. And second, so Fran just mentioned there are some things that we're not going to be able to control, and so we have taken some account for that, but we are going to be providing guidelines to teachers and to students exactly what the expectations are. We haven't completely figured this out 100% yet, but we will likely or are considering asking teachers questions and students questions about, how they completed the tasks. Just some sort of validation or verification of student authentication. So that's all in the works to consider as we figure out how the student submissions are ultimately going to occur.
And I'll just add another perspective. If anyone in here has taught an online course, you have similar issues, similar concerns. And I've taught courses where students submitted things that I wasn't sure was their original work. And I, as a teacher, then had conversations. In class, I can have it face-to-face. Online courses, I called them and I had conversations and asked questions that would confirm to me that it was their work, or bring up concerns and ask me to follow up and make sure that, to my own best understanding, I can either attest that it was their work or indicate to them that I have concerns.
Yeah, so there's some precedence for this already with AP Studio Art, right? Studio Art students submit their digital artifacts and there's some attestation or verification process, and so we'll take a look at that and see how that would be helpful for this process as well too. We also have software that searches for plagiarism and things of that nature. So there's still some discussion left to be had, but we're figuring it out. Mm-hmm. Yes. Other questions? Yes, sir, in the back. So the question was about how a student score would translate into college credit. Is that correct? Yes. Uh-huh. Yep. Right, so I'll start this off. So the College Board has been working with colleges and universities. We have collected a number of university attestations, thank you. And we have over 120 colleges and universities right now that have added their names to a list indicating that they would provide students with college credit and or placement for this course. Obviously, there's still a little more work that College Board needs to do. We're continuing that work with contacting professors, doing site visits, and informing them a lot better about this new and upcoming course. They want to know, they want to see sample questions and figure out what the test is going to be like. That's coming soon. Later this fall, it is expected that we would have a course and exam description that not only would include the curriculum framework components, but will also include sample questions as well too. So all of that will be shared with colleges and universities, and we'll try to build on that pool of the 120 already on that list and increasing that list and getting more colleges informed about this course. But by and large, if we take a look at the participation in our College Board National Pilot, we have university participation there. And certainly there's university participation with the universities that have received NSF grant awards to help train teachers to teach computer science. So, there's a lot of moving pieces as well to support the college and credit placement issues. Comments by the panel?
Just one comment. There are different ways that a course can count for credit in a college. So it can count for computer science credit for the major. It can count for computer science elective credit or computer science credit, but not non-major credit. It can count for general elective credit. So all of those types of situations, are possibilities.
Great.
As well as place you out of a course if your college has a computing requirement, taking some kind of a computer science course, this can place you out of that. So in addition to credit, you can jump past the first course if it's required.
And if you're particular,
I get this, but I'm meaning like in order to present functionally to students.
if your particular school that you're interested in or your students are interested in are having concerns, I would just direct them to the list of schools that have attested. And the list is incredibly impressive. UC Irvine, UCLA, Berkeley, Duke, Harvey Mudd, Stanford, University of Illinois, Urbana-Champaign, Go Illini, University of Illinois, Chicago, Loyola. There are so many powerful schools that have attested that would inspire, I think, other schools to say this is a very legitimate project.
And you see them offering credit for both courses.
Yeah, absolutely. I mean, we do already have, a support for the current APCSA course, which, by the way, will continue. I just needed to state that because I know there's some questions. APCSA is staying, okay? It's not going away. So there's already a list of schools who are providing college credit and or placement for students who score a 3 or more. And, some of them provide that credit and placement for 4 or more, but it's all online, and I can direct you to that information as well.
I understand that they do it now, but with some course,
Yep.
they offer two semesters, say 2 courses.
Yeah.
I find that difficult because I feel like a lot of colleges right now are not giving a lot of credit for that CSA.
Yeah, so that is another issue we're working with the colleges and universities is what if a student takes both courses, right? What kind of credit and placement will they receive? And I think, again, that's going to be a local, type decisions that are made. Mm-hmm. Comment?
I think it really depends on the major the student decides to go. The APCSA is typically the first semester of an engineering course. APCS principles is usually for your non-engineering majors, how it's projected. Now, you never know. A student may minor in something where they would need this and they could get a credit. So, given the amount of permutations, combinations that a student can take, I have a college student right now, and he's constantly fluctuating in the kind of courses he can take. So, if he has it, he's taken both APCSA and APCS principles. You never know where you can get the credit for.
Right, other questions that we can go to. I'll come up here to this lady up front and then back there next. Yes.
The programming part, I know it's not language specific. Like in your classes, like what language did you use, or did you use multiple ones? And then also, like, what are the test questions going to look like since they're not in a certain language?
The question was about programming languages and tools used in the course. Is that correct?
We
Thank you.
probably all three use something different. I use Scratch. You use?
I use JavaScript, but I also allow them to explore the drag and drop like a Blockly environment that they can also see the JavaScript associated with that.
I start with Scratch and I finish with HTML JavaScript.
But I will also add that other tools and programming languages that are used across the pilot are things like App Inventor, Python, Alice. Help me out here.
Java.
C.
Snap.
Oh, snaps. Thank you. So we.
How do you test that? How do you test
So,
Yeah.
you want to answer?
No, go ahead.
There will be a sample exam, so you will not have issues with that. And we'll probably define the programming language we're using, and it won't be anything like any of those that we've just mentioned. Here, this is an if statement and what this does and how to interpret it. So that will be right on the exam or on reference materials for the student when they take the exam. We have only a couple minutes, like 1 or 2 minutes left, so
Yes. There's one last question that I promised to allow.
Well, right.
Oh, I thought we were going to 12.
Are we
So we
good?
do have time. So.
So a follow-up to that is,
Sorry,
Sorry.
I was working under the impression we were in at 12. Too, but- So I'll take a stab at that. So the question, let me rephrase. The question was, are teachers allowed to use the results that students produce on the performance test as course grades for their own purposes? And when should that occur, if that is allowed? We are still working on the guidelines to provide to teachers in administering these performance tasks. I'm only assuming at this point that that will be allowable, and probably the preference would be that the grades for those performance tasks not be given to students until after they've submitted it to the College Board. Again, that's just my assumptions at this point in time. When we do finalize the guidelines for teachers, it will have it clearly laid out, what you should do in the classroom. Yeah. Yep, that will all be included there too. We're still working through a lot of those issues, but certainly the questions about students with needs and with IEPs and things of that nature are important for us. So we'll figure that out as well too. Do you guys want to comment on that?
I was going to say that the AP CSA currently has those type of accommodations where students have the very large books they can write in, or students have
Yep.
someone type in what they speak, and those kind of accommodations I assume will also be a part of the computer science principles.
If I can add, the way I'm thinking of doing this, if a student has to turn in a performance task for College Board, that's an assessment that they are going to grade. But I'm going to prepare them before that, so I'm going to hold some mock exams. Those mock exams, like I do in APCSA right now, I have practice exams. Those can count as a grade. But I don't know that I would necessarily would be right or fair or ethical for me to take the final performance task that is going to be used for an AP grade and grade it in my class somehow or the other. We would not do that in the APCSA. Of course, it's not available to us, but we wouldn't do it even if it was.
Yeah, that's a good point. Yeah, so we're figuring that out again. So, yeah, I'm making a mental note about that because I think that's a good comment to take back. Yep. Okay, question here.
Yeah, if the assessment is done and it's going to be used for a grade by the teacher, it's got to be submitted to the College Board in March or April, way before the end of the year, so that they can grade it and give it back, and then the teacher could base a grade on that. Are you planning to have this stuff all graded by the month of May for the high school students? That is, by have them submitted in March or April, instead of just taking a test in May?
Oh, I see. So I think the clarification to that question is that the gentleman in the back was asking if teachers themselves could provide a course grade to students on their own separately in their classroom. But to clarify, for the student submissions, we'll probably likely follow the same schedule that AP Studio Art has. The submissions are due in early May. And then the scoring of that would occur in the month of June, just much like the same cycle that all other AP exams have with the scoring of the free response questions. The scoring would occur in June, and then scores are provided back to students online in early July. That's just the current process for all AP exams right now. Yeah. Other questions back there? Yes, this gentleman. I'm sorry, you, and then I'll come up here again. Yes.
So, assuming that you can use a grade on that performance task, but you can't give it until after they've submitted it, will there be a mechanism for submitting it earlier? Let's say that they're done with it in, January timeframe. Could we submit it then, so that you have it digitally, then we give a grade to it? I mean,
Yeah.
That's just so that we can give prompt feedback. So
Yep.
It's not just languishing out there as an empty spot in the grade book for months.
Right, so that's a great question, and it's definitely something that College Board staff have talked about, but it's not something that we can answer right now because we're still working on platform development, and it's going to depend on the capabilities of the platform. So if the platform, I'm again, assuming, okay, there's nothing definitive, but if the platform perhaps has capability to track student progress on there and certainly say, and the student indicates, I'm ready to submit, earlier than May, if we had that capability, that's something we would definitely consider, but it's just going to depend on the capabilities of the final platform that we use. Yeah. Sorry? Yes, computers can do that. The management of that, though, is a little bit trickier than you might think.
I could say personally as a teacher, having a student submit in January and then giving them a grade, and then having other students who have the capability of submitting much later could unduly influence those other students. So I'd probably try to keep them all together and have them submit at the same time.
Other questions? Oh, I'm sorry, I said we would come back up here.
I actually have a three-part question that all sort of relates.
Okay.
So the first question is, now that we have these learning objectives and everything else, when are we going to have access to actually how to flesh that out for classroom activities and for, the ongoing instruction that's going to be necessary for the course? So the second part is, what training is going to be provided if you've come up with some idea of how that's going to happen. And we're looking at 2016-17. So my third question related to that is, what's the transition between here and there? And those of us that are not piloting, what would you recommend that we do to be ready when and how for 2016-17?
So, let me see if I can
Yeah, you can take the first part.
start with the first two and then maybe turn it over to them. So the first question is that about availability of the curriculum framework? Or
No, we already have that.
Okay.
It's a question of where are the learning objectives and the actual classroom activities and the
Okay.
potential syllabi, and how do we flesh that out into a doable teaching environment?
All right, so I think that's a very complicated question because there are, different projects that are working on developing curriculum for their teachers that they're working with and so on. The College Board is, is working on development of some of that. We have a pretty much well-defined teacher slate of teacher support materials that we develop for each AP course, including the course description, a practice exam, and some teacher resources like course planning and pacing guides. That's all in development. In addition, we have 4 teaching guide, sort of like curriculum modules that are being copy edited at this point in time, and we hope to make those available in the fall. They're not comprehensive in the sense that they cover everything, in the curriculum framework, but each of them focuses on a different big idea. We have one on algorithms. We have one on abstraction, data, internet, and creativity. Each of those includes 2 lessons with multiple activities, sample syllabi or links to sample syllabi. And we hope to be able to make that available later this fall. Give me until the end of August before you start, pinging me. But all of that will be available online. As far as the other teacher resources, that's not all going to happen until later 2015, early 2016. What was the second part of your question before I turn it over to them?
What training are
Yeah.
you anticipating doing for those
So College Board will be sending out a call for consultants. We will want to have a pool of consultants trained for College Board workshops. Very much like all other AP courses, we'll have our, 1-day, 2-day online and summer institutes available. But again, that's not going to happen until 15-16. Okay, but there's probably a lot more information that the Pilot Instructors and Development Committee can provide for you.
So I don't know if you were at the last session, but there was a gentleman, Seth Pizzo, who said, these are my heroes of the computer science principles movement. And he mentioned the universities associated with the pilot sites. So even though some of them are still formulating their curricula and they're still kind of adjusting to the curriculum framework as it becomes finalized, you could certainly go to those sites. One of them, the gentleman representing, is sitting right next to you, and you could look at their materials. Incredibly engaging, they're freely available, and you get a lot of support from the people running the program, so that would be a good place to start.
So,
There's also the CS 10K community that has resources, and there will be an AP community because this is an AP course. So just as you have an AP CSA community, there'll be an AP CSP community that will be a community for sharing resources. I had one other. How can you start now? If you're teaching any introductory course or even in any computing course, you can take a little piece of the curriculum and integrate a little piece at a time. So in September, you can look at one of the topics that we're doing and just bring it in slowly. And in fact, I would recommend you do bring it in slowly so that you're not overwhelmed with the entire curriculum framework all at once.
I'd like to address the exact last piece that you were talking, how to get yourself ready. Many of these places that Rich mentioned have online resources. I recommend, and again, they're all a flood of information there. Where do you go? It really is a maze. There are videos, there are lesson plans, there are topic outlines. I recommend you go and search for something like the syllabi or the pacing guide. And then you try and say, piggybacking on what Fran said, try to map it to what you have. And now start making your own pacing guide that's unique to yours, and then go back again to these universities and try to pull tutorials and videos the night before we have to teach, and try and do it.
Good questions. Any other questions or comments? Yes, ma'am. Okay, great. Thank you for that. Yes, sir, in the back.
So we're getting multiple places, like I know, probably the way your class, right? Trying to meet the AP CS principles class. We got the mobile CS. How are you making sure that all of this is meeting your needs? I mean, is it collaborating going on there to make sure all these experience?
Yeah, that's a great question. So to paraphrase, the question was, is there collaboration between different organizations in the College Board so that all of the different efforts are aligned really to build curriculum? The answer to that is yes. College Board staff have had conversations with different organizations like Project Lead the Way, and just kind of figuring out what they're doing, and they're kind of also understanding what our timeline is and whatnot. And in addition to that, because I'm in the curriculum and content development group in the Advanced Placement program, we are responsible to have discussions with publishers as well too. We'll hold a publishers webinar for those that are interested in developing textbooks and curriculum resources for CSP, just to provide a lot more information about the curriculum and the alignment issues, and really to provide some guidelines on how we can collaborate on those efforts as well. And that's scheduled to happen sometime this fall as well too. Yeah. Good question. Mm-hmm. Yes, sir.
Is this PowerPoint going to be available?
Oh, sure, I can make that available. I can send it to you directly, or you can, put it up on this site here, that's here, or csprinciples.org, where we work together with Owen on that too. I can definitely make that available. Okay, so we have a couple of minutes left. If there are there any last questions or comments? Well, before we leave, then, I want to thank the panel, the development committee members on the panel. Thank you very much for helping with this session. And we're willing to stick around for a few minutes if you have any additional questions or comments. And please, go back to your schools, go back to your institutions, and talk about CSP. Share this information to everyone. Thank you very much.